So the first one says determine the convergence or divergence of each improper integral. So how do we know it's an improper? Because one of our limits is infinity or negative infinity. In fact, the upper limit on this one is infinity. So what are we going to do? We're going to rewrite this problem. We're going to rewrite it as the limit as b goes to infinity of the integral from 1 to b of, and I'm going to go ahead and write it as x to the negative 3 dx. Okay? So with this, all I want to do, I'm not evaluating the limit until the very end. So let's keep the limit symbol there until the very end. Let's think about this. What's the integral of x to the negative 3? Well, using the power rule, that would be what? X to the negative 2 over negative 2, right? And this would be evaluated from 1 to b. Technically, we would need the plus c. So I'm going to clean this up. It's the limit as b goes to infinity. I'm not evaluating that limit until the very, very end. I'm just cleaning this up. This would be what? A negative 1 over 2x squared, I believe. And that's evaluated from 1 to b. Let's go ahead and evaluate it. Again, keep that limit there. Don't evaluate that to the last step. So this would be negative 1 over 2b squared. And then I'd have minus a negative. So this would be, or minus, that's fine. Negative 1 over 2 times 1 squared. Let's clean all that up, and I'm getting the limit as b goes to infinity of, well, that would be negative 1 over 2b squared, and then minus a negative is a positive. 1 squared is 1, so times 2, so I'm getting a plus 1/2, I believe. And now that that's simplified, I can go ahead and evaluate the limit. I could get a common denominator if I wanted. There's no need to. No need to get a common denominator on this one. I'm just going to evaluate this limit at each term. So if I plugged in or looked at the limit as b goes to infinity, this first function, this negative 1 over 2b squared, is bottom heavy. And so as b gets larger and larger, that denominator gets larger and larger, which means the fraction gets smaller and smaller and approaches the number 0. So it looks like we would have 0 from the first part. 1/2 is a constant. The limit of a constant is the constant. So my final answer in this case would be 1/2. So the question is, determines its convergence. Well, it certainly converges, and it converges to the number 1/2. Okay. Let's look at the second interval here, second integral here. We have the integral from 1 to infinity of 1 over the square root of x dx. Again, this is an improper integral because I have an infinity here. So I'm going to replace that with a b. I'm going to do the limit as b approaches infinity of the integral from 1 to b of, and I'm going to go ahead and write this as x to the, well, square root of x is x to the 1/2, but because it's in the denominator, this would be x to the negative 1/2 with respect to x. Keep that limit there until the very end. So the limit as b approaches infinity of, let's consider this integral, x to the negative 1/2 using the power rule. So that would be x to the positive 1/2 if I added 1 to the power, and then I divide that by 1/2, which is the same thing as multiplying it by 2 over 1 or multiplying it by 2. But again, I need to evaluate this from 1 to b. So let's go ahead and look at this. This is going to be the limit as b goes to infinity of 2 times the square root of x, evaluated from 1 to b, which is the limit as b goes to infinity. I'm going to actually evaluate it. It's going to be 2 times the square root of b minus 2 times the square root of 1. So what is that? That's the limit as b approaches infinity of 2 root b minus 2. And let's think about what happens. So as b goes to infinity, consider that first term. The square root of a large number is a large number. So this first term is actually going to go to infinity. So what I essentially have is infinity minus 2. I mean, it approaches infinity minus 2. A huge number minus 2, which is approaching infinity. Okay, infinity minus 2 is still infinity. So what does that mean? That means the area of under the curve, that it's getting bigger and bigger and bigger, and I'm adding bigger and bigger pieces to it, so there is no number that it converges to. So this is called divergent. Anytime it goes to infinity or negative infinity, after you evaluate the limit, the answer is it is divergent, or the integral diverges. Okay? Let's try another example. Let's look at example 2 together. This one says evaluate the improper integral if possible. So this is the integral from negative infinity to 0 of 1 over x minus 1 quantity squared. This is an improper integral because we have an infinite limit here. So I'm going to say the limit as a approaches negative infinity of the integral of a to 0 of, and then I'll go ahead and write this as what? X minus 1 to the negative 2 power with respect to x. I don't know how comfortable you are with your integration yet, how many times you've, all your integration rules and techniques. For instance, on this one, I know you're going to use a u sub. So this is u equals x minus 1, so du dx would be equal to just 1, so du equals dx. So I'm going to substitute in for u, and I'm going to substitute in for dx. So this is equal to the limit as a approaches negative infinity of, well, this would be the integral from a, technically we should write x equals a, to x equals 0 of u to the negative 2, and then this would be du. So that is something that I can integrate. So this is the limit as a approaches negative infinity, that's an a, of, well, what's the integral of u to the negative 2? Using the power rule, that would be u to the negative 1 over negative 1. And that's evaluated at x equals a to x equals 0. Be very careful. We're not plugging in those values for u. We're plugging in those values for x. So this is the limit as a goes to negative infinity of u to the negative 1 flips it to the bottom. So this is going to be a negative 1 over, and what was u? U was x minus 1. And this is evaluated from x equals a to x equals 0. So now I can actually plug this in. It's the limit as a approaches negative infinity of, plug in 0 first. This would be negative 1 over 0 minus 1. Then plug in a minus negative 1 over a minus 1. Let's clean that up. This is the limit as a approaches negative infinity. Again, keep that limit all the way, every single equal sign, until the last step. Negative 1 divided by negative 1, that's a 1. And then we have minus negative 1 over a minus 1, so I'm going to say 1 plus 1 over a minus 1. So that's a plus sign right there. Okay, let's think about our limit now, of actually evaluating our limit. So if we evaluated our limit on this one, what would we have? The limit as a goes to negative infinity. Well, that first term is going to go to a 1. That second term is going to go to a 1 over, well, that would be a negative infinity minus 1. That's going to still go to a 0, because that's a really large number on bottom, so the fraction goes towards 0. So it seems to me that we have a 1 plus 0 in this case, which is simply 1. So what was the integral from negative infinity to 0 of 1 over x minus 1 quantity squared? It does converge. It does converge, and it converges to the number 1. Even though it's an infinite limit, an infinite area, or an infinite region that we're trying to integrate, find the area of, it does converge to the number 1.